Waste management and recycling. What is the problem at hand? Waste management is about handling trash responsibly, but when waste is not properly managed, it leads to pollution, health problems, and wasted resources. Recycling can help solve this, but many places lack systems to make it work effectively. In 2017 and 2018, Kuwait produced between 37 to 43 million tons of waste annually, including excavated soils and construction debris, which is a very worrisome. What causes this problem? The problem arises from excessive waste generation, limited recycling systems, and improper disposal practices. It occurs in residential, industrial, and commercial sectors, affecting the environment, public health, and the economy. Kuwait's waste management challenges stem from over reliance on single use plastics, a lack of efficient recycling infrastructure, limited awareness of proper disposal methods, and rapid urbanization. Household waste accounts for around 4% of total waste, or 1.4 million tons in 2019. Are there any natural causes of this issue? In Kuwait, the decomposition of organic waste in landfills is a significant environmental concern, particularly due to the extreme heat. Organic waste makes up approximately 40 to 50% of solid waste globally, and similar trends are observed in Kuwait. This high percentage, combined with the temperatures that often exceed 50 degrees Celsius, creates a perfect environment for accelerated anaerobic decomposition. How have human activities contributed to this problem? Excessive consumption, reliance on plastics, and insufficient waste management systems drive the problem. High consumption of disposable items and poor waste segregation.
Step 3, Abel. What are the consequences of this issue? Human health. Microplastics enter the food chain through water and seafood, leading to health issues. Plastic chemicals seep into drinking water, causing contamination and potential health hazards. Environment. Marine animals ingest or become trapped in plastic waste, resulting in biodiversity loss. Toxic chemicals from plastic pollute soil and water, harming plants and wildlife. Society. Plastic pollution ruins beaches, parks, and public spaces, reducing tourism and outdoor enjoyment. Economy. Governments face high costs for cleaning up plastic waste. Healthcare expenses rise as pollution related diseases become more common. Which SDGs are most relevant to the problem? Goal 6, Clean water and sanitation. Plastic pollution contaminates water sources, threatening clean water access. Goal 12, Responsible consumption and production. Mismanaged plastic waste highlights the need for sustainable production and recycling practices. Goal 13, Climate action. Reducing plastic waste decreases greenhouse gas emissions from productions and incineration. Goal 14, Life below water. Plastic waste severely impacts marine ecosystems and biodiversity.
Step 4, Impact. How handpicking and magnetic separation help solve the problem and contribute to SDGs. Handpicking. How it helps solve the problem. Waste sorting. Handpicking allows manual separation of waste materials like plastic, paper, and glass, reducing contamination in recycling streams. Hazard removal. Isolates harmful items like batteries and e-waste. Contribution to SDGs. SDG 12, Responsible consumption and production. Reduces waste sent to landfills by enabling recycling and reuse. SDG 11, Sustainable cities and communities. Improves waste management practices, leading to cleaner urban areas. SDG 1 and 8, Creates employment opportunities for informal waste collectors and promotes economic growth. Magnetic separation. How it helps solve the problem. Efficient metal recovery. Separates ferrous metals like iron and steel from mixed waste streams, ensuring their recycling. Reduces landfill waste. Diverts metal from landfills, conserving landfill space. Minimizes environmental impact. Prevents hazardous metal components from leaching onto soil and water. Contribution to SDGs. SDG 12, Responsible consumption and production, supports recycling by efficiently recovering metals for reuse. SDG 13, Climate action, reduces the carbon footprint associated with mining raw metals. SDG 6, Clean water and sanitation, prevents water contamination caused by improperly disposed metal waste. How does each technique work? Handpicking separation. Handpicking is a simple manual method of separating substances based on size, shape, or color. It involves picking out the unwanted substances by hand. Magnetic separation. Magnetism is a separation technique used to separate magnetic materials from non-magnetic materials. A magnet is brought close to the mixture, and the magnetic materials are attracted to the magnet, leaving behind the non-magnetic materials.
Steps involved in separation. Magnetism. Prepare the mixture. Place the mixture containing magnetic and non-magnetic materials on a flat surface or in a container. Bring the magnet close. Hold a magnet near the mixture without touching it at first. Attract magnetic materials. Move the magnet slowly over the mixture. The magnetic materials will be attracted to the magnet. Separate the magnetic materials. Collect the magnetic materials that stick to the magnet and set them aside. Hand picking. Inspect the mixture. Spread the mixture on a clean surface so all components are visible. Identify the unwanted substances. Look for the materials you want to remove based on size, color, or shape. Separation and environmental problems. Magnetism. How it works. Magnetism separates magnetic materials like iron, cobalt, or nickel from non-magnetic waste. Environmental application. Used in recycling plants to separate metals from other waste. Handpicking. How it works. Handpicking separates visible, unwanted materials like stones, plastic, or debris from a desired product or environment. Environmental application. Used in waste management to manually remove large pieces of recyclable or hazardous materials before processing. Observation and results we saw during the experiment. The handpicking was more efficient since we were limited by the weak magnet that we had. According to our results, if we had a better magnet, then it would have been more efficient. Comparing. Magnetism. Effectiveness is better for solving environmental issues on a large scale, recycling plants and industrial cleanups. Benefits. Speed. Works quickly to separate large quantities of magnetic materials. Cost effective. Requires minimal energy to operate once the magnets are in place. Limitations. Only works for magnetic materials, so it cannot separate non-magnetic substances like plastics or organic wastes. Initial cost. Requires investment in magnets and equipment for large-scale operations. Handpicking. Effectiveness. Handpicking is more effective for smaller scale or localized cleanups. Benefits. Simplicity. Does not require any equipment, making it accessible and easy to use. Versatility. Can remove a wide range of unwanted materials that are easy to see. Limitations. Labor intensive. Requires significant time and human effort, making it impractical for large-scale operations. Inefficiency. Can be slow and less effective for separating small or mixed materials.